In today's lesson, we're going to look at Chapter 23, Section F on the hypergeometric distribution. Let's start by reviewing the material we covered in the last section. Using the example, we'll select 3 people from 5 females and 4 males, and we'll calculate the probabilities of all the possible different outcomes. First, we could select no females and 3 males. And to calculate the probability, we would use this notation. Again, a combination of selecting no females out of 5 and 3 males out of 4, divided by the total number of combinations, which is selecting 3 people out of 9. We used our calculators to do the math for us. We get 1 times 4 over 84, and that's going to get us a probability of 4 over 84. Likewise, I can find the probability of selecting 1 female and 2 males. Here again, we'll have a combination of 1 female out of 5 and 2 males out of 4 over the same total number of combinations. That gets me 5 times 6 over 84, or 30 over 84. I can also find the probability of selecting 2 females and 1 male. Again, 2 females out of 5 times 1 male out of 4 over the total number of combinations. That gets me 10 times 4 over 84, which is 40 84ths. Bear with me as I do the last possible outcome, which is 3 females and 0 males. Again, 3 out of 5 females times a combination of 0 males out of 4 all over the total number of combinations. That gets me 10 times 1 over 84, or 10 84ths. Remember from our work on probabilities earlier in the year that if I have accounted for all possible outcomes, then the probabilities of those outcomes should add up to 1. And indeed, we see that these probabilities add up to 84 over 84. So I'm accounting for 100% of the possible outcomes when we're selecting 3 people from a committee of 5 females and 4 males. If we take a look at the expressions for the probabilities of selecting this committee, we see that it follows a pattern. If X represents the number of females chosen for the committee, then we can write the probability of selecting the committee in the general form, like so. The probability of selecting X females is going to look like this. The combination of selecting X females out of 5 times the combination of selecting 3 minus X males out of 4 all over the total number of possible combinations, which again is 3 members out of 9. Using the notation, or another one of the notations that we learned in the last video, I can also write this as 5 over X times 4 over 3 minus X all over 9 over 3. This is called a hypergeometric distribution. Manufacturers often use hypergeometric distributions in their quality control sampling. For instance, if you have a production line that's producing widgets, a quality control engineer will sample a certain number of those widgets every day, and he'll look for defects in those widgets. Say he samples 20 and he finds that 3 are defective. He can use hypergeometric distributions to calculate the probabilities of all the defective widgets being produced that day. The general form for a hypergeometric distribution can be written as follows. N is capital N is defined as the population size. This is your total number of widgets. D is the number of known defects in your population. X is simply a series of integers like 0, 1, 2, 3, and so on. I'm going to show you how to use the hypergeometric distribution in an example. Let's say we're a manufacturer that produces dinner plates, and we have a batch of 20 dinner plates where we know 5 are defective. If 3 dinner plates are randomly selected, what is the probability that 2 will be defective? We should split the population into 2 parts. We'll have defective and okay components to the population. Think of this as male and female in the original example that we did at the start of the video. If we want to find the probability that 2 of these plates will be defective, we need to look at the subsets of the population in total. I know that there are 5 defective plates. There must be 20 minus 5 okay plates, or 15 okay plates. So the probability of selecting 2 of the defective plates when taking 3, I can set up the following expression of combinations. Let's take the defective first. What's the probability that I'm going to choose 2 of the defective out of 5, which leaves me with the combination of choosing 1 of the okay plates out of 15. And again, we have to divide this by the total number of combinations, which is 3 out of 20. Using my calculator, I can calculate these combinations, and they turn out to be 10 times 15 over 1,140. So my probability of selecting 2 defective plates out of 3 is 0.132. That was part A. Let's take a look at part B. Now I want to find the probability of selecting at least 2 defective plates out of 3. Now I have 2 paths I can follow, so we're really going to use the sum principle here. My 2 choices are selecting 2 defective plates or 3 defective plates. Well, I've already done the first part. If I select 2 out of the 5 defective plates and 1 out of the 15 okay plates, this is the expression for that probability. I need to add that for to the expression of choosing 3 defective plates out of the 5 and 0 okay plates out of the 15. If I do the math here, I'm going to get 10 times 15 over 1,140 plus 10 times 1 over 1,040. And this is going to give me a probability of 0.140. Again, we'll practice more of these in class tomorrow.